Welcome back to Max with RP. In the earlier video, we had started to understand what are increasing and decreasing functions. We also saw some examples. We will explore more about these functions, when they are increasing, when they are decreasing, when they are neither increasing nor decreasing, etc. Look at this problem. F of x is minus 2x cube minus 9x square minus 12x plus 1. Find the intervals or where the function is increasing and decreasing. Intervals of increase and decrease. Where f is increasing and decreasing. Now, f dash of x, okay, in the earlier video, we had discussed the definitions and we also saw that in the case of an increasing function, f dash of x is positive. The slope is positive for an increasing function, and for a decreasing function, the slope is negative. That is, f dash of x is less than 0. As you know, dy by dx is nothing but slope of the tangent to the curve at a particular point. So we are going to use that definition to identify what are the critical points. What are the critical points? Critical points are points where if I draw a tangent to the curve, it's going to be parallel to the x-axis. So the function either increases or decreases before the critical point, and then it changes its course of its direction. There are some special cases which also we will discuss. Now look at this here. F dash of x is minus 8x square minus 18x minus 12. So this is, okay, I have differentiated f of x, sorry, minus 6, minus 6x square minus 18x minus 12 is the derivative, which is minus 6 into x square minus 2x minus 3 plus 2x plus 3. Since I have taken minus outside, minus 6 outside, x square plus 3x plus 2. This is minus 6 into x plus 1 into x plus 2. Because 2 plus 1 is 3, 2 into 1 is 3. 2 into 1 is 2. So we have factorized minus 6x square minus 18x minus 12 as minus 6 into x plus 1 into x plus 2. So the real line minus infinity to infinity can be divided using the critical points. What are the critical points? Minus 1, if I equate this to 0, where all does f dash of x become 0? X is equal to minus 1, x equal to minus 2. So we have divided the real line through these 2 points because they are the values of x for which if I draw a tangent to the curve, it is going to be parallel to the x-axis. They are the points where f dash of x is 0. These points are called as critical points. Okay. Now, let us see. So we are going to divide the real line into these intervals: minus infinity, comma minus 2, minus 2, comma minus 1, minus 1, comma infinity. Okay, so these are the intervals. As to how, sub-intervals as to how we are dividing the real line. Then How do you know a function is increasing or decreasing? You have to study f dash of x. So nature of f dash of x, or rather I should say sign of f dash of x. Then that will help us to understand the nature of f of x. Okay, so what is f dash of x? We have to be very careful. Do not forget this negative sign here. So this is your f dash of x. Minus 6 into x plus 1 into x plus 2. Now, let me choose a value in the interval minus infinity comma minus 2. So can I choose minus 5? Okay. Then what will happen to f dash of x? So I am putting x is equal to minus 5. So I already have minus 6. Minus 5 plus 1 minus 4. Minus 5 plus 2 minus 3. Minus 6. Minus 5 plus 1 minus 4. Minus 5 plus 2 minus 3. You can easily see it is negative. So sign of f dash of x is negative. So the function is decreasing. Next, I have to choose between minus 1 and minus 2. So let me choose x is equal to minus 1.5. Now what will be the sign of f dash of x? When I choose minus 1.5, already minus 6 is there. Minus 1.5 plus 1 will give you minus 0.5. Minus 1.5 plus 2 will give you plus 0.5. So you can easily see it is positive. So the function is increasing. Okay. Next, the last one, let me choose minus 1 to infinity. Let me choose x equal to 0. F dash of x will be minus 6 into 1 into 2, which is negative. So the function is decreasing. Okay. So we have divided minus 2x cube minus 9x square minus 12x plus 1. Okay. We have factorized it, found the critical points, and then we have understood that from between minus infinity to minus 2 the function is decreasing. Minus 2 to minus 1 it is positive, therefore the function is increasing. Beyond minus 1 it is decreasing. So okay, this is a sign diagram. Okay, so you can, through signs we are indicating the nature of the function. Minus infinity to minus 2 the function is decreasing, increasing, decreasing. See, I want to also observe what happens to this function using GeoGebra. Okay, minus 2x cube minus 9x square minus 12x plus 1. Minus 2x cube minus 9x square minus 12x plus 1. Now let us explore this using GeoGebra. Okay. Now what is the function that we were seeing? F of x equal to minus 2x cube minus 9x square minus 12x plus 1. Okay, we differentiated. We got minus 1 and minus 2 when we differentiated. In case you have forgotten, do you remember we wrote f dash of x as minus 6x square minus 12x minus 12, which is minus 6 into x square plus 18x, x square plus 3x plus 2. This is minus 6 into x plus 2 into x plus 1. So what were the critical points? Minus 1 and minus 2. So, or what do you mean by critical points where the tangent is parallel to the x-axis? So, what are the coordinates of A and B? Critical points are the points where you can see to the left of B. What is B? This is the point B. What is A? This is the point A. To the left of B, the function is decreasing. Okay, that is minus infinity to minus 1, the function is decreasing. Now, minus 1 to 2. Oh, minus 1 to 2, the function is increasing, you can see. Okay, at A again, what is the slope here? M is 0. Why? That's a critical point. That is where the tangent is parallel to the x-axis. So, A is again a critical point. Now, to the right of A, what happens? The function is decreasing. So, minus infinity to, this is, what is this point B? The x coordinate of B is minus 2. Till that the function is decreasing. Minus 2 to minus 1, the function is increasing. Minus 1 to infinity, again the function is decreasing. Okay, if you want, you can move the, the tangent and also check. If I move the sorry. So, have you all understood till this? Okay, now I can move the tangent. See, this is A. You can see M is 0. Okay, now if I move the tangent here, you can see the slope is negative because the function is decreasing. If I move A this side, you can see the slope is positive because the function is increasing. Now at B again, M is 0. Okay, the slope is 0 because the tangent is parallel to the x-axis. It's a critical point. Now again, if I keep moving, you can see that the slope is negative. So it is decreasing, increasing, decreasing. So algebraically also we solved, and then we also saw it using GeoGebra. Is it clear? This is a sum that we had proved, which I showed you using GeoGebra. Now look at this problem. F of x is equal to x power 4 minus 4x. What will be f dash of x? 4x cube minus 4. This is 4 into x cube minus 1. 4x cube minus 4, 4 into x cube minus 1, which is 4 into x minus 1, x square plus x plus 1. You all know that x square plus x plus 1 here, b square minus 4ac will be what? 1 negative, so only x is 1. Is the only possibility. Now divide the real line. Minus infinity, 1, infinity. Okay. Now what is your f dash of x? 4x cube minus 4. Okay. Now when x is 1 is the only critical point, to the left of the critical point, what is the behavior of the function? We have to see. So intervals sine of f dash of x, nature of f of x. Okay, the intervals will be, what is the first interval? Minus infinity to 1. What will be the sign of f dash of x? This is f dash of x. So let me choose a value between minus infinity to 1. Okay, you know that 0, I can choose a very easy value, that is 0. Now f dash of 0 will be, when I put x as 0, minus 4, so which is negative. So that means what? The function is decreasing. What about 1 to infinity? Okay, I can choose f dash of say 5. What is f dash of 5? Or in fact, I can use 2, easier to calculate. F dash of 2. F dash of 2 will be 4 into 8 because 2 cubed minus 4, which is greater than 0. (32 minus 4, 28, which is greater than 0. So here it is decreasing. Between 1 to infinity, it is increasing. So 1 to infinity, it is positive, it is increasing. What about this x square plus x plus 1? Please note the discriminant is minus root of b square minus 4ac, which is less than 0. So it has got only one real root, which is x equal to 1. So I have found the critical point. Which is a critical point? X equal to 1. And then we have divided the real line into intervals. Minus infinity to 1, the sign of f dash of x is negative. So f of x is decreasing. 1 to infinity, sign of f dash of x is positive. So f of x is increasing. Is it clear? Now we are going to explore this again using GeoGebra. So what is the function we are looking at? F of x equal to x power 4 minus 4x. X power 4 minus 4x. Okay. So I have to type in the input box x power 4 minus 4x. X power 4 minus 4x. So what did we get when we solved that equation? F dash of x was 4x cube minus 4, which is 4 into x cube minus 1, which is 4 into x minus 1 into x square plus x plus 1. Now I have done, here it is x cube, 4x cube minus 4 is the derivative. So what is the function? X power 4 minus 4x. Now, so what is the point where the tangent is parallel to the x-axis? X equal to 1 is the only critical point. So let me now take, are you able to follow? This is what the sum we are discussing. So x equal to 1 is the only critical point. To the left of 1 we saw that so this is x equal to 1. So at 1 you can see the tangent is parallel to the x-axis. Okay, so if I take the tangent, to the left of 1 it is decreasing, to the right of 1 it is increasing. So let me now clear this, only then I can use the tangent tool. So this is the tangent tool. Okay, so I'm going to just click a point A. First let me click a point. And then let me draw a pair of tangent. Select the point, select the curve. I got the tangent. I also want to write down the slope. So click on this, click on slope and click on this line for the slope. Slope is negative. Can you see? Because we are looking at you can see that the function is decreasing. So the slope is negative. So to the left of 1, the slope is negative and the function is decreasing. Now, let me move this point. What do you observe? The slope is negative. Now the slope is 0 at x equal to 1. When is the slope 0? At A. What is the x coordinate of A? 1. So x equal to 1 is the critical point. That is the point where the tangent is parallel to the x-axis, where f dash of x is 0. That is why it is called the critical point. To the left of the critical point, the function is decreasing. So minus infinity to 1, the function is decreasing. Now look at 1 to infinity, the function is increasing. So as I move the point A, you can see the slope is increasing. The slope is always positive. M is the slope. Wherever I write, you can see the slope is positive. So I hope you enjoyed this session. So now we explored actually two problems. We solved them algebraically and we also verified them using the tool of GeoGebra. I hope you have started to understand what is an increasing function and what is a decreasing function. Okay, and we will go ahead with more and more problems and more ideas and more thoughts in the next video. So until we meet next time, please go through the entire video, go through the GeoGebra, try to practice, try to share it with your friends if you find this video useful. Until next time, goodbye.